Hey guys, go back through and make sure you watch that first one on proportions. I kind of gave the idea that I think, again, with chapter 7, when we do the inferential statistics, it's so easy to get bogged down on these intense formulas and all these crazy numbers that we're kind of losing sight of what it actually is. What we're doing in chapter 7 is we're taking a sample set and we're making a decision on a population. We're inferring based on our sample to what we predict the population is going to represent. I'm going to leave. I'm going to go to the other camera. I'm going to leave the light off this time because I did notice a lot of glare on it. Hopefully the natural light works out for us. This is for 7.2. This is when we're talking about a mean. And I think this is the one too, that when I heard students saying that they had tried Googling this, I know that most of the time it comes up with mean. Remember that 7.1 is what you would call your proportion. If you Google those, I think the mean is often the default one, but it's the same idea. The formulas look a little bit different, but this is one where I think students may have more comfort. I know that right now you're going to see that weird formula, your margin of error, and go back and watch the other video if you've not yet. But when we're looking for the mean, they show this weird Z alpha over 2 times the standard deviation over the square root of n. Remember that again, this whole Z, every time we're going to see it, we should be just forcing ourselves into the memory. This comes from the table. The 90 is your 1.645 is your Z-score. 1.96 is your Z-score anytime you see the 95, and your 2.575 is your Z-score anytime you see the 99. Now, this one is going to be a little bit more easier and probably even, I want to say, a little bit more intuitive as to what we would need to do. Now, I will add a side note. This could be, and this is a question that I get a lot, a T-score. The difference between a T-score, for lack of better purposes, and it gives a great definition in the book, but a T-score is if we don't know our population standard deviation, or more likely, the T is anytime you have a small sample size. And again, that can vary greatly depending on what kind of book or even the examples. I know that even Pearson can vary on that sometimes. Typically, this is anytime you're less than 30 is kind of like your rule of thumb. I've heard it as low as like less than 50. But what we want to think of with this is a T-score is any kind of a sample we collect. If I want to find an average, I'm not going to go to 3,000 gas stations and find out the average price of gas. If I want to find the average price of coffee, I'm not going to go to 3,000 Starbucks and find out how much they're charging. That would be your Z anytime you're talking big number. I'm probably going to go to 10 gas stations and get a good guess. I'm probably going to go to maybe 12 coffee shops and get a good guess. It's that number that is reasonable for what we would do is kind of what my normal recommendation we would do. I'm not going to go to 1,000. I'm going to go to about maybe, I don't know, 15, maybe 35 is how many students could be in a class. That would still be kind of fall under your T. It's kind of that gray area, but it's a small sample. Now, here's what happens. We still have our point estimate. The point estimate is, if I can spell it correctly, your best guess, your best estimate for what's going to happen. It's, again, what I call the middle of the interval. This one is, in this case, your mean. So, for example, I'm going to make numbers up again. You'll be able to plug this in. You can plug it into a calculator, but again, I'm going to show us how to use StatCrunch to do all the heavy lifting for us, because in all of this in StatCrunch, you're going to punch it in, you're going to see your lower bound, you're going to see your upper bound, you're done. It's no work. All you need to do is just punch in, and even with the StatCrunch as we've seen, export data, click, click, compute, done. What we're looking for, let's say the average, let's say the mean for the average gas cost. I'm going to go to the closest 10 gas stations going down Jefferson Davis. Okay, the average gas cost is $2.79. I'm making the number up. I'm going to go and I'm going to plug in, because I can punch this all into StatCrunch or into my TI. Standard deviation, right? We're expecting a small number. I'm going to guess maybe, I don't know, 0.12. Who knows? You plug that number in. That 2.79 is your middle. You're looking for, what is my lower bound? What is my upper bound? I'm going to need to come up here and find my margin of error. I'm going to subtract it. I'm going to add it. And what you're going to do is plug that in. Okay, plug in my 1.645, plug in my 0.12, I think I said, plug in your square root. It's going to do all the work for you. We add that in here. I'm going to say that I get a margin of error of 0.31. And again, you can go through and do all of that work. I'm more interested right now in describing what a confidence interval means and what all of that crazy computation means. I'm not as worried about the computation in the hieroglyphics right now. I'm worried about the interpretation. I'm going to add that 0.31. I'm going to minus that 0.31. I'm going to add that, and that'll be 8. That'll be 310. I'm going to subtract that, and I'm going to get 4.8. And remember, what this means is we were talking money. We were talking the average gas price is $2.79. We're saying now that my lower bound is $2.48. My upper bound is $3.10. And what that means is, again, at the end, I can be 95% confident that no matter what gas station I go to, the gas price is between $2.48 and $3.10. Now, again, we can go through, we can crank through all that formula. But I'm going to encourage us, and in a video coming soon, I'm going to show us how to use StatCrunch. All StatCrunch is going to do is it's going to say, this is your LB, this is your UB. And what that means is, and you punch those into right on your MyMathLab, when it enters it, it just says, what is this to this? And it has you write those in a box. You just punch in 248 and 310. That's the easy part, but I think students lose track of what that meant was your mean was the middle. You're adding the margin of error, and that's going to be your upper bound. You're subtracting the margin of error. That's going to be your lower bound. I'm looking for gas. How confident can I be that gas is between those two prices? That's what a confidence interval means to us.